Why is it so that always metals are used in wires and not woods? And why plastic is always used in switch? The answer is pretty simple, right? Because we need conducting materials in wires and we need insulators or non-conducting materials in switches. There are certain properties that sets these two kinds of materials apart. In this video, we are going to discuss such properties like resistance, resistivity, and conductance. So, without any further delay, let's get started. Whenever there is some charge trying to flow in a material, the material offers some opposition in the way of this flow of charge. This opposition offered by the material is known as resistance. So, this resistance is basically some opposition force in the way of movement of charge. And this resistance is dependent on some physical parameters of the material. Suppose the material is of length L and it has a cross-sectional area of A. Then the resistance offered by this material will be directly proportional to the length L and will be inversely proportional to the cross-sectional area A. So if the conductor is very long, the resistance will be higher, and higher the cross-sectional area of the conductor, lesser will be the resistance. So if we combine these two with a proportionality constant, we can write R, which is the symbol for resistance, equals rho times L by A, where L is the length of the conductor and A is the cross-sectional area of the conductor. And if we talk about the unit of this resistance, it is expressed as ohm. And now let's talk about this rho. So from the previous equation, we got R equals rho times L by A. So if we try to write expression for rho, it will be R times A by L. So this rho is called resistivity or specific resistance of the material. So suppose the material is of unit length and it has a unit cross-sectional area. Then the resistance offered by this material will be called its resistivity. So resistivity is fixed for a specific material, and the unit of this resistivity we can deduce from the above equation. The expression for rho is R times A by L, and the unit for R is ohm, and unit for A is meter square, and unit for L is meter. So the unit eventually becomes ohm meter. So the unit of resistivity or specific resistance of any material is expressed in ohm meter. Now let's talk about conductance. Conductance is just the reverse of resistance. So resistance means some opposition in the way of flow of charge. Then conductance will mean the ease of flow of charge or current through a conductor. And this conductance is expressed as G, and we can write G equals 1 by R. Then we can write 1 by rho L by A, which is the expression for resistance. We already seen that. Then we can write 1 by rho times A by L, and we can write this 1 by rho as sigma, where this sigma is called conductivity, which is exactly opposite of the resistivity. So if we talk about the units of conductance is called mho or ohm inverse, or it is also called Siemens. And if we talk about the unit of conductivity, it is just opposite of resistivity. So the unit of resistivity is ohm meter. So if we inverse ohm meter, it will become 1 by ohm meter, and 1 by ohm is also called Siemens. So the unit eventually becomes Siemens per meter. So Conductance is the ease of flow of charge in a material, and conductivity is nothing but specific conductance. So guys, that's all for resistance and conductance. I hope you liked the video. If you did, please leave a like and comment below if you have any queries or suggestion. And please consider subscribing to this channel because we upload this kind of videos twice every week. So I'll see you in the next one. Till then, bye bye. Take care.